So for what we're going to, the questions that we're going to do, we'll need this, right? We'll need to know the convergence test. So I'm just gonna remind you the convergence test. Just gonna remind you the convergence test. Yeah. So with the convergence test, remember the convergence test says that if the summation of an converges, then the limit as n approaches infinity of a of n will be equal to 0. You see, right? So this is what the convergence test says. So now we know that if we let me do this. We know that if we try to do any series, then we find that it converges. This simply tells us that the limit of that series should be equal to 0. You see, right? Then the limit of the a of n of that series. Then when we come to divergence test, here we know that if this one says that I think we can have yeah, we have to talk about the limit first. It says that if the limit as n approaches infinity of an is not equal to 0, then the summation of an will diverge. You see, right? So we know that if I take the limit now of an, I find that it's not 0. So I know that this thing was going to diverge the series. So now we're going to say that since we know these, we remember how the divergence and the convergence series are, then we can look at the comparison test, how to state a comparison test and how to state a limit comparison test. Then we do at least 3 questions. I would have, yeah, I think, let me see. I want us to start with just the comparison test. So now when we come to stating a comparison test, we know that this says that, let me create a new page. This says that, let's say, a comparison test so this says that if I suppose that we have 2 series, which one is the original one, right? That we have 2 series, which is an, the summation of an and summation of bn, with both of them being positive. You see, right? This happens for all n. Then also, if we have that an is less than bn for all n, then this will happen. First one, if we take the summation of bn, we find that this is convergent. You see, right? And then this an will also converge. Secondly, so let's do this. Here we say this. We say that an is less than bn, so it means that an is the smaller one, bn is the bigger one. If bn converge, in other words, when I say bn converges, in other words, it goes down. You see, it approaches 0. When it converges, this is 0. When it converges, it will go down, forcing a of n to go down also. You see, right? Meaning that a of n will also converge. You see, right? Then now, we say that if, now we look at an, the one which is inside. We say that if this an is divergent, then we can say that also the summation of bn is also divergent. Then if this one diverge, in other words, it goes up, it will force bn to also go up. Is that right? To diverge. But then we can break this into two, right? Let's say I want to consider this. Yeah, let me do this. Let's say I want to consider this. Let me come and do this. Now, but I think let's just consider, instead of giving you a lot of information, I think let's consider that when we are doing questions. Then I'll show you what I mean by that. So, but we could consider this fact that we can come and say this. We can come and say this. Remember, from the guide, right? We suppose that we have two series an and bn, with an and bn being greater than 0 for all n. Then we come here, we just subtract this. When we come here and do this, let me show you this, and I'll do that. If you want the previous information, you'll find it on the recording. Then if we want to break it into two, considering both, because we can have two cases. We can have that an is bigger than bn. We can also have the case where bn is bigger than an, which is what we'll be dealing with inside. So when it comes to stating, though both are correct, we're going to have to go with one, and we'll decide which one we'll go with. So if I suppose this, right, for all n, then the first one is that if the summation of bn converges, you say, right, the summation of bn converges, and let me say, and an is less than or equals to bn, then the summation of an is also convergent. You say, right. The second one, remember that one said that if that one on number 2, it said that if summation of an is divergent, which, comparing it while an is smaller, it's correct, right? But when we come to divergent part, I want us to look at this and say that we don't want to look at an and say it's divergent or convergent. I want us to always check bn. We must have a syntax, is that right? I want us to always check bn. So we're going to say if this bn is divergent, and now an should be bigger. There on convergent it's less, here it should be bigger than bn. Then summation of an is also divergent. So I'll draw that thing again. If I draw it here, this is the first one say that bn is bigger, an is small. You say, right? If bn converges, meaning it goes down, an will also converge. Then the second one, it says now that an is bigger, bn is small. If bn diverges, if bn goes up, an will be forced to go up. You say, right now. So I want us to move with this one, because we can have two cases. So it's not always the case that an will be less than bn. It can be bigger than bn. So now if you come to the limit comparison test, So here's what happens with the limit comparison test. The limit comparison test is used after the comparison test has failed. When the comparison test fails, we try this one. We try this one called the divergence test. After divergence test fails, also we try limit comparison test. Limit comparison test won't fail. You see, right? So now here we're going to do the same thing. We suppose here the only difference is that, remember here you suppose that both an and bn are greater than 0 or equal to 0. Here bn cannot be equal to 0, so we must restrict that. So we're going to suppose, so we're going to have the same thing. We're going to suppose that we have two cases, or two series, not two cases, two series, the summation of an and summation of bn with, check here now, the only difference that I'm gonna say there, an greater or equal to bn, greater or equal to 0, and bn, oh, this one will only be greater than 0 because it will be in the denominator for all n. You see, right? And then we'll define c being equal to the limit as n approaches infinity of an over bn. You see, right? So now we say this. We want to discuss the convergence now. We say that if c is positive, meaning c is greater than 0 and is finite, meaning c is less than infinity, you see, right? Then either, this statement has marks, you see, right? Then either both series converges or both series diverges. So that's how we're gonna conclude. This statement will be used to conclude this one of either, from either both series converges or both series diverges. You see, right? And then last time I gave you problems, I said like you should do these problems. So the first one was, from the problems that I gave you, the first problem was that if I'm given summation n equals to 1 over n squared plus 1 squared. First, the question is, how do you answer this? First, you let an, you should always do this, always, right, whenever you're answering. First, you let an, whenever you're answering these ones of comparison test. Then you do this now. You check bn. Bn, I can get it by reducing this. Then I'll be left with 1 over n squared squared. Then I'll get 1 over n to the 4. You see, right? Then I compare. First, this is comparison test, don't forget. First, I like to I check this condition first. I check that condition so that I can know, should I focus on the convergence or divergence? You see, right? I know, so I can know. If an is bigger than bn, I'll try to focus on the divergence. If an is less than bn, I'll focus on the convergence. So here's how I'm going to do it. Let's check. Is an, you remember an is what? Is equal to 1 over n squared plus 1 squared. Is it greater or equal to this one? Is it greater or less than this one? Let's see, is it greater? An? So I would plug 1 first. When I plug 1, what do you get? We get 4. When we plug 1 here, we get 1. So it means that an is bigger than this one, which is bn. You see, right? When an is bigger, I'll focus on the divergence test. Yeah, not necessarily divergence test. I'll focus on the divergent part. I know I must focus on divergent part. So we come and do this. Now I get that. Then I check this now. I check the summation. You see, first I checked whether this is bigger or less than this. After here, I come and check the summation of Bn. That is, does it converge or diverge? Then I can now come and conclude here. So what I do, I'll draw this aside. I'll draw this the graph aside and say our AN is bigger, right? It means that AN will be here. So that whenever I prove, I know whether I'm doing the correct things or not. And then I said that this will be the summation is n equals 1 of, I'm talking about Bn now, right now. And this, by comparison test, no, not by comparison, but by the p-series test, it will converge. By p-series test converges. Bn converges by p-series test. You see, right? And by the comparison test, I want to see whether this will converge or diverge. You see, right? By the comparison test, just because Bn converges doesn't necessarily mean that this one will also converge. I must come and confirm. You see, right? So I come back here. Bn converges. In other words, Bn goes down. When Bn approaches 0, this An is not approaching 0. Check, An will remain constant. You see, right? You see, right? When Bn converges, An doesn't move because it's on top. You see, right? It doesn't move. It's not affected. So it is inconclusive. Then, by comparison test, this is inconclusive. You see, right? When it is inconclusive, second test that I check. Remember, I sent this in the group. I sent this other picture in the group where I wrote these things. I was like, if comparison test fails, then you must check divergence test. If the divergence test fails, then you must check this one, the limit comparison test. So now when I check the divergence test here, first I must look at An. Ask myself, if I find the limit of An, will I get 0? If yes, then don't use divergence test. Then here, when I use that here, I'll get 0 plus 1. 1 squared is 1. So I won't get 0. So divergence test will work. Then I say that by divergence test, let me use a different. By divergence test, you see that this is equals 1, which is not equals to 0. Hence, the series this one will diverge. You see right? Then that series will diverge. Any question? Is there any question? So from now, yeah, I think that yeah, I think I'm in my network. So now let's try another question. So the second question is as follows. We have two. We have the summation. Let's see, n equals to 4 of n squared over n to the third minus 2. And then we're going to let an be equals to n squared over n to the 3 minus 2. And then our bn will be equals to now when I check this, I will have to reduce the denominator first, then I have n squared over n to the 3, which is 1 over n. Then I ask myself, we know that an is equals to n squared over n to the third or minus 3 or minus 2. I ask myself, is this bigger than this? When I plug, we're starting from 4, right? When I plug 4 there, I will find that. So you can just plug 4 and check which one is bigger between the two. When I plug 4 here, I'll find that I get 0.26 something. Here I get 0.25. So that means that an is big. So an is bigger than 1 over n, which is equals to bn. You see, right? And then, now that I know that this is the case, then I'll check the summation of bn. And we know that this one is divergent by harmonic series. That we know. Now I can draw that diagram and check what will happen to an. We know that an is bigger than bn. An is bigger, bn is small. So if bn diverges, it goes up. It will force an to also go up. You say right? So it will force an to also go up. And then we know that also an will diverge. So the harmonic series or p-test series where p is less or equals 1. So we say that it will diverge by this. And so this one is also divergent by the comparison test. You say right. Then we come to the third one. Third question. The third question now, we're going to have this. We're going to have that. Let me do this. The third question we have. Now we're going to have that we have the summation infinity n is equals to 2, 7 over n plus 1. You see, right? So first, what I'm going to do is let an be equals to 7 over n plus 1. You see, right? And then I check bn. Bn, if I multiply this denominator, I'll have something like 7 over n squared plus n. I can reduce this n, which is the non-dominating term. So I'll be left with bn being equals to 7 over n squared. So I check an, I know that an is 7 and n plus 1. I check, is this greater or equal to bn? So I know it will be less, right? So in this case, if this will be less, if an will be less, then I can easily check this 7 n squared, which is equal to bn. So I know that an is less. So I can easily come and check the summation of bn. Bn is what? 7 over n squared. You see, right? Then this we know that it's 7 summation. It's n equals to 2. And this is 1 over n squared. So from here, I know that by p-series test, the series will converge. You see, this is what p equals to 2, which is greater than 1. You see, right? Then now let's draw that diagram and check. Gonna draw that. We know that an is less, so bn is bigger, an is less. And we found that bn does what? Bn converges. In other words, bn will go down. When it goes down, it will force also an to go down, meaning they will both converge. You see, right? Meaning they will both converge, meaning they're going to both converge. So I'm going to say this. I'm going to say that, and so by the comparison test, the series, then I write the series, right? This series 7 over n plus 1 will converge. You see, right? Then now I come to, let me do one last problem from this. I think let's hope this problem also includes a limit comparison test. And then we come to 4. We have, this is starting from 7 over n squared minus 2n minus 3. First, I let an be equals to 4 over n squared minus 2n minus 3. And then bn will be 4 over n squared. Then when I check this, I realize that an, which is 4 over n squared minus 2n minus 3, will be less than 4 over n squared, which is equals to bn. Then I can draw that diagram. This is bn is bigger, an is small. Then now I come and check the summation of bn, which is 4 over n squared, which is equals to 4. So now this. And we know that by the p-series test, the series is convergent because we have p which is equals to 2, which is greater than 1. You see that? And so we check this one now. Let's go check. When bn converges, when bn goes up, an will remain constant. You see right now? Did it converge or diverge? Oh, bn, let me see, bn. Yeah, it converged. Yeah, when bn converges, it means that an will do it. When bn converges, yeah, it did converge. When bn converges, an will also converge. So, yeah, I think this is the case. Let's check here. Let me see something. Is this one bigger than this? No, no, no. Here, this one is big. Let me do this. AN is bigger, BN is small. So this one gives us the case to say that when BN converged, right? Yeah, when BN converges, AN will remain constant. You see, right? AN remains constant, but BN converges. You see, right? Then since we don't know what AN is, right? Then we'll say that this is inconclusive. Remember I said that when something is inconclusive here, we must, when it comes to comparison test, we must now check the divergence test. When I look at this AN, I must ask myself, can I find the limit to be not zero? No, the limit will be zero. So we know that by divergence test, this will be inconclusive also. So I must use the limit comparison test. You see, right? The limit comparison test says that, now already I've stated those things up there, right? I know that AN is that. So now what I'm going to do, we know with AN greater or equals to 0, BN greater than 0, and now I'm going to have this. C will be equals to, I'm going to define this C, AN over BN. And our AN in this case is 4 over, I think this is n squared minus 2n minus 3 over our BN is 1 over, it was 4 over n squared. We see, right? Then this will be equals to the limit. So I can just multiply, the simplest way to simplify this, I can just multiply this one by n squared over 4 over n squared over 4. You see, right? The limit as n approaches infinity, so this can cancel out the denominators. So this will be 4 n squared over 4 n squared minus 2n minus 3. So the 4 will cancel out. Then we'll be left with the limit as n approaches infinity. When I check this, the highest degree is n squared. So if I consider these two, already I know that the others, if I factor out n squared, the other will become 0. So this will give us 1. You see, right? So this will be equals to 1. So I might as well come and write 1. And this 1 is greater than 0. So if this is greater than 0, the limit comparison test is that either both series will, or either both series converge or both series diverge. Is right? So I'm saying that this will occur, either both series will converge or diverge. Then I check the summation of Bn. This is starting from 7. Then that one Bn is 1 over n squared. And I said this by the P series test. We know that by the P series test, this is what converges, which is what P equals to 2 greater than 1. You see, right? You see, and so this one again will converge by the limit comparison test. So yeah, I'll stop here for this ones, since I've shown all the 3 cases which I wanted to talk about.